Hey, welcome to Electric TV. I'm Tom Green. Well, I'm sure you're aware of what solar energy is, and I'll bet you know what wind power is as well. But I'm going to throw out another green phrase that you may have heard, but may not understand how it works. A fuel cell. In some cases, a fuel cell can produce electricity that is 300% more efficient than other fossil fuels. Well, they're popping up all over the United States, and they're generating electricity for homes and factories right now. ETV's Dominic Geritano headed out to see one of the fuel cells in action near San Francisco.
Chris, good morning.
Morning, Dominic.
How are you?
Pretty good, thanks. How are you?
Thanks for taking a few minutes to show us your fuel cell.
My pleasure.
What is a fuel cell?
A fuel cell is a device that takes the energy in a fuel and electrochemically converts it to electricity and heat. So basically in a fuel cell, you need a fuel and you need oxygen. The fuel is basically taken from a readily available fuel source such as natural gas or biogas. The oxygen is obtained from air, and these two components, they undergo an electrochemical reaction, and the byproduct is electricity, which you get at a very high efficiency, and heat, which you can then use for your process needs in your facility.
Now, we're at a wastewater treatment facility, and the biogas you were talking about, I certainly can smell,
Right.
But that actually is an important part of the process.
It is. Basically, the wastes that come in are treated by the wastewater treatment facility, and one of the byproducts of that treatment is called anaerobic digestion of the waste, creates methane. And that biogas, which is rich in methane, is used as a fuel source in the fuel cell.
So let's go take a look at it.
Sure.
Okay. Okay, on the back side of the fuel cell now, it really looks like three different components back here. Maybe let's talk about these and kind of what goes on.
Yeah, before we go into those three components, I wanted to say that fuel cells are efficient because they convert the energy without going through the combustion process. Because they don't go through the combustion process, there's none of the pollution that's associated with combustion. There's no NOx, there's no particulate formation. These things are associated with conventional ways of producing electricity where you have to combust a fuel. In a fuel cell, everything happens electrochemically in this magic box that we call the fuel cell. Going back to the three components of the fuel cell, one is the mechanical balance of plant, which is to the far left there. That is a system which basically processes the fuel and the air, which is required for the fuel cell reactions to take place.
So that biogas.
The biogas,
okay.
Yeah. It treats it, cleans it up, brings it to the right temperature to make the fuel cell happy. So this thing here in the middle is the fuel cell. That's the magic box. That's where all the electrochemistry happens, and the fuel is converted to electricity and heat. Now the electricity coming out of a fuel cell is DC power, which is not really useful for common use. So that DC power has to be converted into AC power, and that is done by the third component of the fuel cell, which is the system you see to the far right there.
Well, let's walk around and check it out.
Sure.
Okay. Okay, this is really getting down to the brass tacks here.
That's right. This is the mechanical balance of plant of the fuel cell. This is where we have the different systems to process the fuel and the air and make it suitable for use in the fuel cell. This also houses the control system of the fuel cell. As you can see, our fuel cells are unmanned plants. They operate by themselves automatically, and this is the computer system that controls all the control functions of the fuel cell. There's a screen here with a user interface, and that basically tells the different components of the fuel cell what to do in order to make the system work and generate electricity.
Now, it's funny to kind of mention as we stand here, it's really quiet.
Yes, fuel cells are very quiet. We're almost 2 or 3 inches away from this, and we can have a regular conversation without raising our voice. And if you think about it, Dominic, right here we're making sufficient electricity to power more than 500 homes.
These three parts that we just saw is enough power for 500 homes?
That's right.
Wow, that's unbelievable. Any byproducts through this process?
Of course, fuel cells generate high-grade heat, which can then be used in your process.
Okay, let's check it out.
You have to keep in mind too, where solar is efficient while the sun's out. These run 24/7. So if you're in a place of business that's open from 9 to 5, from 9 to 5, this fuel cell is feeding the grid. But from 5 o'clock till 9 o'clock the next morning when your business is shut down, this is still feeding your grid.
From an electrical point of view, they're about between 40 and 50% efficient. The numbers we see are usually 45 to 47% efficient on the electrical side. And then when you add the heat, so you're using combined heat and power, and you can use that heat in the facility, they're approaching 90%, and in some cases over 90% efficient.
Okay, the exhaust from the fuel cell. Tell us what's going on here.
Well, so here you have the clean exhaust coming out of the fuel cell at a high temperature, and it's being sent into this heat exchanger, and it's being used to heat water. Now, the exhaust from a fuel cell, high temperature fuel cell, can be used to either make hot water or generate steam, or also be used to generate cooling in an absorption cooler. This particular facility, they're making hot water.
And what are they using that hot water for?
They're using the hot water here to keep the digesters warm and keep the bugs happy so that they can keep generating the methane.
And the methane goes into the fuel, which makes the electricity, and we go round
Exactly.
and round. Yeah. Chris, let's go ahead and talk finally about just the need for a trained, safe, qualified workforce to install a fuel cell.
Yeah, as you can see, Dominic, this is a fairly sophisticated piece of equipment, and there's different components that have to be integrated in the field, and you need qualified electricians and technicians to put these things together.
Not anybody off the street can do this kind of work.
No, you need to be qualified. You need to be aware of the national codes, local codes, so that you could do the installation in a safe and proficient manner.
Well, Chris, thanks.
Okay, we are outside the EnWaste Inc. fuel cell turbo expander facility. You can see it in front of you there. This is about an 8-foot fence that surrounds it, and that's about how big it is. That is actually EnWaste regional headquarters behind it. There's about 1,200 people that work in that building. You can see a little bit of a plume coming from the stack there. They tell me that's water vapor, and I don't know if you can hear, there is a little bit of noise that comes. Most of the noise I'm hearing is coming from right over there where the gas is depressurized. There's also a fairly busy street here, so you're going to get a lot of traffic noise. I'm not sure how much of the fuel cell noise you can hear. The traffic is actually considerably louder. But that's it. There are some benches over here where their employees sit during the summertime. And that's about what would be visible from a fence. They tell me the facility proposed for Trumbull will be the same footprint. They call it 2 tennis courts. There will be twice as many fuel cells, arranged a little bit differently, but they will not take up any more space, they tell me.